Hello, welcome back for part two. So, what we're going to look at to start with for this part is Lincoln's index. So, Lincoln's index is a way of estimating the population by first capturing a sample of a population, and the population has to be a mobile species. Okay. We then mark the sample, and the mark needs to be permanent, so it doesn't rub off or anything like that in water, but it needs to make sure that it doesn't sort of affect the ability of the animal to survive. We then next capture a second sample after a delay. And this delay is really important because it allows our first sample to move freely within a wider population, hopefully so that it becomes evenly spread. And it doesn't just all remain clogged up in one place, because that would affect your results. And then we count how many of our second sample are marked. And from this, we can work out a ratio basically and identify the total, or an estimate of the total population. So our formula is this. It is total population equals number in our first sample, so N1. We multiply that by the number of our second sample, and we divide both of those by the number in the second sample that are marked. Okay, and this will give us a estimate of the population. So, for example, if I have I capture 5 woodlice. These are my woodlice. I capture 5 of them. So these are my 5 woodlice from, let's say, my compost heap at home. I need to mark them, so I use some sort of permanent paint pen or something just to mark the back of the caprice, the sort of shell that's on the woodlice. I then release them back into my compost heap. It smells it's a bit hot. I then come back a week later, or 24 hours later, or 48 hours after a delay, and out of my compost heap, I capture another 5 woodlice. Two, 3, 4, 5, and on the 5th one I find that it comes with one of my red pen marks. So if I want to work out my Lincoln's index for this population, estimate the population, my population will be equal to the number in my first sample, which is 5, multiplied by the number in my second sample, which is 5, divided by the number that is marked in my second sample, which is 1. So if we simplify that, my population is equal to 5 times 5 is 25, divided by 1, so that will equal 25. Obviously not very many woodlice in my compost heap. I'd expect to see a few more than those, so I need to go seeing what's going on in my compost and see if it's actually turning into nice compost or if it's just turning into slime. Now there are some limitations to the Lincoln's index, and it's important that you are aware of these so you can sort of quote them in an exam, or if you're doing this for real life. The organisms need to be mobile, so they can freely distribute themselves within, and you need to be able to catch them. A key one is that the size of the population does not significantly change between captures. Okay, so like there aren't any big sort of birth events like loads of woodlice hatching in my example. There aren't any significant death events that kills loads of them off in one go, so no one's put some sort of insecticide into it. There's no migration occurring or big movement, so all my woodlice aren't going to pack up and go south for the winter. The capture and marking does not affect survival. Helps if you can spell, doesn't it, really? There we go. So you don't want to put like a massive, great big neon flashing light on to something because it's going to get eaten and that's going to affect your results. And related to this, the mark doesn't fall off or get washed off. So it does have to be appropriate. You might need to test this just to make sure that what you're using is appropriate. That the marked individuals can mix freely so that your ratios aren't going to be thrown off, and that all individuals in a population are equally likely to be captured. So you don't have any sort of they only, like some individuals, like males only come out in the day and females come out in the night or something, and then you for some reason do your second capture at the different time of the day because it's going to completely throw your results off. So that is Lincoln's index and its limitations.